Hello all, happy to be back with you. It's been far too long. The calendar, months have changed, the weather's gotten colder. It's just been too long since I've been able to do one of these kind of nerding out videos here. So excited to be back, and today diving into a topic that has really been of interest to me of late, which is explainable AI. Sometimes called XAI for short, but to me that makes me think of Grok or its products. So I'm gonna just call it explainable AI. But basically, artificial intelligence, AI, is making decisions for us all the time. It's in everything from our social media feeds to our Netflix accounts to whether or not we're approved or denied for a business loan. But how does it make those calls, right? How does it determine its outputs? And that's often a complete mystery, a total black box, if you would. So today I'm going to try to kind of pry open that box a little bit as we take a look inside the world of explainable AI. So let's just imagine this for a second. You apply for a really important loan and you get denied. Not by a person per se reviewing it, although there's probably a human in the loop as well, but by an algorithm, by a system, a computer that just says no. And you're left kind of hanging, wondering why. What was the reasoning? What's the thing that tipped the scales? And without an explanation, you have no way to correct the problem or even appeal the decision. That's where explainable AI comes into play. It's an emerging field that can help navigate issues of transparency, building trust, providing greater clarity on AI usage, AI outputs, and AI governance. And thinking beyond my analogy of banking, criminal justice, where AI is predicting, reoffending risk, hiring algorithms that might be screening resumes, medical diagnosis or approval for treatments, self-driving cars making split-second decisions. I actually got to ride in my first Waymo last month in Phoenix, and I thought it was incredible. There's a video here of just me and a couple robot vehicles on the road one Phoenix morning. Somebody asked me, would you feel really safe when you were riding in that? And I said, yeah, probably too safe. There's a part of me that was like, let's go, let's get up and go. But every single one of these cases, or a bias or an issue, can have devastating consequences. So yes, the technological power is incredible and amazing, but the lack of transparency can cast a really long shadow. And that is the core challenge that explainable AI is trying to solve. The goal is to make AI models more explainable, intuitive, and understandable to human users. And it's not just one thing either. It could mean different levels of explanation to different people. Like a data scientist needs one kind of detail to debug, regulator needs another to audit, and the person affected by the decision, the user, they might need something completely else. Now, how does explainable AI actually provide that clarity, especially for models that maybe were built to not be transparent per se in the first place? Well, generally, it falls into a couple of main groups. One approach is trying to make the AI inherently transparent right off the get-go, right from the start. This often means using simpler models though, so maybe things like decision trees or linear regression, where you can literally trace the logic. The downside is these simpler models just aren't as powerful or as accurate as the big complex black box models. The other approach that's kind of at the heart of the explainable AI field is to use post hoc explainability. So basically these are techniques that you apply after the black box model has already made its decision, right? You don't change the model itself. And for you and I, maybe you don't have the skill set to do that in the first place, but you can interrogate it. And this is kind of adjacent to the videos I've done on AI hallucination, right? I want to provide kind of practical, high-level overview of these topics, but also things that you or I or everyday users might be able to think about and maybe implement, or on an organizational level implement. So really there's two areas or levels of explanation in the post hoc explainability area. One is global explanation, so that's explaining the model's overall behavior across the entire data set. This is incredibly helpful for business stakeholders, regulators, areas of compliance. Then there's local explanations, which is insight into why a single or specific decision was made, and helpful for debugging, for individual user feedback, and that type of explainability. There's tools like SHAP or lime. I'll leave this up for a second. It's a really interesting and fascinating dive into these. But the big picture is SHAP or Shapley additive explanations. It's based on Shapley values from cooperative game theory, and it attributes the prediction's outcome to its input features. Calculates the average marginal contribution of a feature across all possible combinations of features. Lime approximates the complex model's behavior by a simpler interpretable model in the local vicinity of a single prediction. So kind of that check and balance with another more localized model. And then you have the partial dependence plots, permutation feature importance. And really what it is it's measuring the marginal effect of one or two features on the predicted outcome, or measuring the importance of a feature by seeing how the model's performance decreases when that feature is added or taken away. Methods that focus on local explanations. They zoom in on one specific decision. A really interesting type to me is counterfactual explanations. So they basically answer the question, what's the smallest tweak I could make to the input to get a different outcome? Which I thought was a really great mindset to have and way to approach this. So back to our banking example from earlier, right? If someone got denied a loan, the counterfactual might say, look, if your rent payments had been on time for 6 months straight instead of just 5, the AI would have likely approved you. Finding that single data point, that single determining factor, or more specifically, like where does that happen? Where does the output change based on the removal or the additive of a factor? So it gives you that concrete, actionable feedback, right? Or image recognition, you might use saliency maps to see which pixels in a photo were the most important for the AI's classification. Like in the instance of it might focus on a cat's ears, right, to determine that it is a cat. But here's the really critical part. Explainable AI aims to give clarity without sacrificing performance or prediction accuracy. The goal, the aspiration is to have both a powerful, accurate AI and the ability to understand, debug, and trust it, and build that trust by opening up the process, being able to trust the process, as it were. I'd say shout out to the 76ers, but Bucks for life. This is exactly why explainability matters so much. For us, the users, it builds trust. For governments, it's about making sure that companies comply with regulations. And for the developers, it's absolutely essential for debugging and just making the AI better and better. All right, so it sounds great, right? Everybody's on board, explainable AI. That's fantastic. What do we do with this information? Beyond just wanting to educate and myself and provide this video as partial education, what do we do with this information? How do we tangibly use it? What are ways that we can look at our usage of AI or organizational use of AI, AI governance, and how this actually matters or is implemented in a daily life and daily operations? First and foremost, I think you need to prioritize the context. So implementers must recognize the trade-off between explainability and performance in most cases. Again, I would like to see the goal of having both, but the required level of explainability often depends on its context. I saw someone say it's the difference between the AI that Netflix uses to recommend new shows or movies to you, which is questionable sometimes, versus a medical diagnosis that might be using some form of AI or AI system, right? Personally, I would be very fascinated by both and explainability in both. Very curious what data is trained on for Netflix in particular. Maybe that's another video for another time. The point is, high-stake models such as medical, finance, autonomous vehicles, they demand high transparency for the reasons stated before. It's also very important for implementing into a trustworthy AI framework. So a framework that would include things like fairness, accountability, confidentiality. There should also be explainability. So for you, for your organization, if you are utilizing some form of AI-driven SaaS product, to know that that is included in your governance of that resource, of that asset. Speaking of governance, establishing formal governance. If you're an organization that is utilizing an AI-driven tool, you should have some form of formal governance standard policy in place. And within that, included with explainable AI, is the human in the loop element. So it's crucial, involving human experts to monitor model behavior during execution and intervene to address biases, ethical concerns, inaccurate outputs, and all of these things. And again, especially driven by context and use case. And finally, the implementation is just for users, just for you and I as people, as individuals, understanding that AI systems can drift, which is becoming less accurate over time, or produce misleading information called hallucinations, even when providing the reasoning. And so just as users interacting with this incredible tool and the myriad of incredible tools that AI has already produced and will just continue to grow and grow exponentially, to keep that mindset of really demanding explainability from the systems that are being used, and especially the systems that we might put trust in for some part of our operations, for some part of our processes, for some part of our organizations. In the end, explainability is not just a checkbox. It is not just a cool technical feature. It's a cornerstone of what is called responsible AI. It's a fundamental pillar, and it stands alongside others like fairness, so models don't discriminate, robustness, so they can't be easily tricked, and transparency, as I've mentioned. But think about it. Without the ability to explain why an AI is doing what it's doing, you can't really prove if it's being fair or robust or accurate, or if it's staying true to its intended use. It's kind of the pillar that holds all the other pillars up in this responsible AI framework. So I'll leave you with this final thought to chew on. When is a good enough explanation, an explanation that can be actually understood, better than a slightly more accurate black box? That's the ethical balancing act that's really at the heart of explainable AI and at the heart of our AI-driven present and our AI-powered future.